Hello, welcome to Python and R for data science, machine learning, and artificial intelligence with 500 days run dataset. So today I'm going to share with you the course modules. We're going to break it down what we will be covering in this course. So to begin with, module one, we will look at introduction to data science with Python and R. And then module two will cover statistical measures. Module three will look at data acquisition and cleaning. Module four, exploratory data analysis. Module five, future engineering. And then in module six, we look at introduction to machine learning. Module 7 will cover model building and evaluation. Module 8, deep learning. Module 9 is model deployment. Module 10, gathering and preprocessing the 500 days run dataset. Module 12, 11, we look at exploratory data analysis with 500 days run dataset. Module 12 will be the actual building of predictive models with the 500 days run dataset. We will be using the real world applications, so we are going to look at the real world applications and case studies in module 13, and then module 14 will be conclusions and next steps. So let me break down each module, what are the chapters that we are going to be covering. So in module one, under introduction to data science with Python and R, so we are going to look at so we are going to look at in chapter one, we will look at the overview of data science, where we are going to define. Let me zoom. Yeah, I think this one is much clearer. So where we are going to look at the definition of data science and its significance in various industries. We look at the introduction to data science life cycle and its stages, for example, data acquisition, data cleaning, exploratory data analysis, modeling, evaluation, deployment. So we will have a brief introduction about those areas. Then in chapter two will look at the introduction to Python and R, where we are going to talk about the brief history and evaluation of Python and R. We will look at the comparison of Python and R in terms of syntax, libraries, and applications. So you'll be able to understand why these two languages are commonly used in machine learning and data science. Then we'll also look at the advantages and disadvantages of using Python and R for data science. And then in chapter 3, we will be setting up the development environment where we'll be installing Python and R on different operating systems, Windows and Linux specifically. And then we will look at introduction to integrated development environment or IDEs such as Jupyter Notebook that will be used in this course a lot. RStudio, which we are also going to be using a lot, and then Visual Studio Code, PyCharm. So those are the IDEs that we will be using in this course. We will also look at configuring the development environment for efficient coding and collaboration. So that all those will be covered in chapter 3. And then chapter 4, we will look at the basic syntax and data types in Python and R. So we're going to talk about variables, data types, for example, numeric in Python, character in R, logical, and data structures like lists, tuples, dictionaries, arrays, and data frames. And then we also look at the control structures like loops, conditionals, and functions in Python and R. Then we also talked about basic operations and manipulations with data types and structures. In chapter 5, we are going to introduce Jupyter Notebook. So we are going to have audio Jupyter Notebook as an interactive computational environment, creating and running code cells in Jupyter Notebook for Python and as well as in R. We will also look at writing the markdown cells for documentations and explanations. Then we'll also look at chapter 6, which basically will focus on version control and collaboration. So we'll talk about we're going to introduce you to version control system, for example, Git, and the platforms, which is GitHub and GitLab, but mostly we'll be using GitHub in this course. We will also cover the basics of using Git for tracking changes, collaborating with others, and managing code repositories. And then integrating version control into Jupyter Notebook and RStudio projects. In chapter 7, we will look at best practices and coding standards. So we are going to talk about the guidelines for writing clean, readable, and maintainable code in Python and R. And then we also talked about the introduction to coding standards and style guides, like for example, Pep 8 for Python, Google's R style guide, which is for R. And we will also look at the importance of documenting your code and using meaningful variable names, comments, and docstrings in your code. Then we will move to chapter 8, where we will be working with data files. So we'll be reading and writing data files in common formats like CSV file, Excel, JSON, XML, using Python and R. But more specifically, we will focus on CSV file and JSON file and then Excel. Yeah. We are going to introduce also the libraries and packages for data manipulation and analysis. For example, pandas, which is used in Python. We will talk about matplotlib. We will talk about numpy, and then also dplyr, which is used in R. In chapter 9, we'll look at the introduction to data visualization, where we'll talk about the basics of data visualization principles and techniques, overview of Python libraries, matplot, for example, matplotlib, seaborn, and in R packages like ggplot2 for creating visualizations. We will look at the examples of simple plots and charts to represent different types of data. And we are using the real world data set, which is 500 days run data set. I always collect them by myself. So you can also collect your own. Yeah, that is the most important thing about this course. It's practically based. In chapter 10, under module 1, so we will look at exploring additional resources, where I will introduce you to online resources, forums, and communities for Python and R users. Example like Stack Overflow, how you can get help from there, Reddit, Kaggle, yeah. And then also we give recommendations for books, tutorials, and online courses to further enhance Python and R skills. After completion of Module 1, we will move to Module 2, which will cover statistical measures. So the continuation of chapter 11 will talk about the introduction to descriptive statistics. So we'll look at the definition of descriptive statistics and its importance in data science. We'll look at basic statistical measures like mean, median, mode, range, variance, and standard deviation. Understanding the central tendency and dispersion of data. In chapter 12, we will look at probability distributions, where we are going to talk about the introduction to probability distribution, like normal distribution, binomial, nominal distribution, Bayesian distribution. We look at the characteristics of probability distributions, like the shape, mean, variance, and then the applications of probability distribution in data science and decision making. In chapter 13, we look at exploratory data analysis techniques. So we will begin by looking at the overview of exploratory data analysis and its role in understanding data patterns. Graphical techniques for EDA like histograms, box plots, scatter plots, density plots, and then we also look at the numerical techniques for EDA, the correlation analysis, skewness, kurtosis, yeah. Then after that, we will move to chapter 14, where we'll be looking at sampling and estimation. So we will look at the definition of sampling and its importance in statistical inference, types of sampling methods like random sampling, stratified sampling, cluster sampling, and then estimation techniques like point estimation, interval estimation, confidence intervals. After completing that, we are going to move to chapter 15, which is hypothesis testing. So we look at the basic hypothesis testing, like the null hypothesis, alternative hypothesis, and then the significance level. We look at steps in hypothesis testing, the formulation of hypothesis, selection of test statistic, calculation of p-value, interpretations of results. Then also the common hypothesis tests like the t-test, chi-square test, ANOVA, and so on. Chapter 16 will cover regression analysis, where we'll talk about the introduction to regression analysis and its use in modeling the relationship between variables. We look at simple linear regression, like the model formulation, estimation of coefficients, interpretations of results, and then also multiple linear regression, where we'll talk about the extension to multiple predictor variables, model diagnostic, and we will go to chapter 17, which will talk about the time series analysis. So we begin by looking at the definition of time series data and its characteristics, components of time series, trend, seasonality, cyclical variations, irregular fluctuations, and so on. Then we'll also look at techniques for time series analysis like decomposition, smoothing method, forecasting, and we will go to chapter 18, which will look at non-parametric statistics. So where we are going to talk about the overview of non-parametric statistics and its advantages, over parametric methods. We look at non-parametric tests for comparing groups, where we look at the main Whitney U test, Wilcoxon sign rank test, Pascal-Wallis test, and then the application of non-parametric methods in real-world scenarios. Chapter 19 will look at advanced topics in statistical modeling. So where we are going to move to the introduction to advanced statistics models like logistic regression, generalized linear models, time series models, and then also look at the model selection techniques, where we'll talk about the AIC, archaic information criteria, Bayesian information criterion, and cross validation. We also look about the model interpretation and validation, like assessing the model fit, checking the assumptions, and interpreting the coefficients. In chapter 20, and then we will look at Bayesian statistics, where we'll look into detail the basics of Bayesian statistics, Bayes theory, prior and posterior distributions, likelihood function. We will look at Bayesian inference techniques, like the Markov chain Monte Carlo methods, Bayesian hierarchical modeling, and then the application of Bayesian methods in data analysis and decision making. So those are going to lay the building blocks in our data science, machine learning, and artificial intelligence course with our 500 days data set. So in module 3, we'll talk about data acquisition and cleaning, where we'll continue from chapter 21, which is understanding data acquisition. So we'll talk about the definition of data acquisition and its importance in the data science workflow, different sources of data, databases, APIs, web scraping, sensor data, surveys, and etc. And then we will also look at the considerations for selecting and accessing data sources. Chapter 22 will look at data loading and importing. So we will look at different techniques for loading data from different file formats. If it is a CSV file, Excel file, JSON file, XML file, SQL databases. Then we looked at the introduction to libraries and packages for data loading in Python, for example, pandas, and R, for example, read R, read Excel. We will move to chapter 23, which will be about data cleaning basics. So look at the importance of data cleaning in data analysis and modeling. Identifying and handling missing values, detection, imputation, deletion strategies, and dealing with duplicate records and inconsistencies in your data. In chapter 24, we will look at data transformation and preprocessing, where we looked at the techniques for transforming and reshaping data, like normalization, scaling, encoding categorical variables. And then we will go to future engineering, where we'll be talking about creating new features from the existing ones, extracting useful information from text, dates, and other sources. Then we will also look at data aggregation and summarization. That can be grouped by the operations, pivot tables, or summarizing data for analysis. After that, we will move to chapter 25, which is data integration and merging. So merging data sets, that will be combining multiple data sets based on common keys or indices. We'll talk about the join types, like the inner join, the outer join, left or right join, cross join, and then handling data conflicts and inconsistencies during merging. In chapter 26, we'll be looking at data quality assessment, assessing data quality like in terms of validity, accuracy, completeness, and consistency. Then data profiling techniques. So we look at summary statistics, data distributions, value frequency analysis, and look at data cleaning pipelines, like developing systematic approaches for data cleaning and validation. After completing that, we'll move to chapter 27, where we will look at the outlier detection and treatment. So that would include identifying the outliers uh, using the statistical methods, example, the Z-score, IQR visualization techniques, and also strategies for handling the outliers, like the removal, transformation, insorization, robust statistical methods. After that, then we'll go to chapter 28, which will talk about handling time series data. So we'll begin with the introduction to time series data and its characteristics, techniques for handling time series data, resampling, interpolation, time-based slicing, and common pre-processing steps for time series analysis. In chapter 29, we look at text data cleaning and preprocessing. So cleaning and preprocessing text data like tokenization, lowercasing, punctuation removal, stop word removal, stemming, and lammentization. We'll also look at handling special characters, the encoding issues, and other text-related challenges. Then we'll talk about the introduction to natural language processing, libraries, and tools for text processing. Chapter 30 will wind up Module 3, where we'll talk about advanced data cleaning techniques, addressing data quality issues like the anomaly detection, data profiling, data auditing, and machine learning based approaches for data cleaning, like automated error detection and correction. Then dealing with large scale and streaming data, which can be distributed data cleaning techniques, real time data validation. So after we will go to module 4, where we will begin looking at exploratory data analysis, EDA. So that will continue from chapter 31, where we'll begin looking at the introduction to exploratory data analysis. We'll be looking at the definitions and importance of EDA in data analysis process, the role of EDA in understanding data distributions, identifying patterns, and detecting the outliers. Then chapter 32 will look at descriptive statistics and data summarization. So we'll be covering the overview of descriptive statistics like mean, median, mode, variance, standard deviation, and also summary statistics for numerical and categorical variables. So we'll talk about the count, the unique values, and frequency, and so on. And then we will wind up with techniques for summarizing and visualizing data distributions, like in terms of histogram, box plots, frequency tables, and so on. Chapter 33, we will look at univariate analysis. So analysis of individual variables. So that would include the distribution, central tendency, and then the spread. We'll also look at visualization techniques for univariate analysis, histograms, kernel density estimation, bar plots, pie charts, and so on. Chapter 34 will cover bivariate analysis. So we'll look at the analysis of relationships between two variables, correlation, association, dependency. And we'll also cover visualization techniques for bivariate analysis. So that we'll talk about the scatter plots, line plots, heat maps, pair plots, and we will go to chapter 35, which is multivariate analysis. So look at the analysis of relationships between multiple variables, talk about the correlation matrix, it map, and then the techniques for visualizing multidimensional data, like the 3D plots, the parallel coordinates plot, and so on. Then we'll go to chapter 36, which is handling missing values and outliers. So that one will look at the identification and treatment of missing values, the imputation, deletion, interpolation, and also look at detection and handling of outliers, which is visualization method, statistical techniques, robust estimators. Remember, in our introduction, we'll be talking about, we would have laid the foundation about this. So in chapter 37, talk about data transformation and future engineering. So that will talk about the techniques for transforming and scaling data. So we'll look into details, the normalization, standardization, and then the log transformation. And then we also look at future engineering methods like creating new features, encoding categorical variables, handling date and time variables, and so on. Then we'll go to chapter 38, which is exploring time series data. So look at introduction to time series analysis, trends, seasonality, cyclic patterns, and techniques for visualizing time series data, like the line plots, seasonal decomposition, autocorrelation plots, and so on. After completing that, we'll go to chapter 39, which is exploring text data. So we're going to look at the analysis and visualization of text data, what frequency, what cloud, sentiment analysis, and techniques for pre-processing text data, tokenization, streaming, lamentization, and then stopwatch removal. Chapter 40 is advanced visualization techniques, where we're going to talk about the introduction to interactive and advanced visualization libraries, creating interactive visualizations and visualization geospatial data. Then we'll go to chapter 41, which is statistical tests and hypothesis testing in exploratory data analysis. So we'll go into the introduction to statistical test for EDA, which will include the t-tests, chi-square tests, ANOVA, and then the application of statistical tests for comparing groups, detecting differences, and exploring relationships. So that would bring us to module 5, which is future engineering. We'll begin with the definition and importance of future engineering in machine learning, role of future engineering in improving model performance and interpretability. Then that would make us continue to chapter 43, where we look at future extraction techniques. So we are going to look at the overview of future extraction methods, manual future engineering, domain knowledge, automated future extraction, techniques for extracting features from raw data, text features, image features, temporal features, and so on. Then chapter 44 will be looking at handling categorical variables. So look at the introduction to categorical variables and their representation in machine learning models, techniques for encoding categorical variables, like one-hot encoding, label encoding, target encoding, frequency encoding, and then handling high cardinality categorical variables, like grouping rare categories and future hashing. That will lead us to chapter 45, dealing with missing values. So look at strategies for handling missing values during feature engineering, im- imputation techniques, mean and mode imputation, regression imputation, and then techniques for encoding missing values as a separate category. In chapter 46, future scaling and normalization. So that will cover the importance of future scaling for machine learning algorithms, techniques for future scaling, like the min-max scaling, standardization, Z-code normalization, Z-score normalization, robust scaling, and so on. Then also look at normalization techniques for handling skewed distributions. Chapter 47 will look at creating interaction features. So that will cover the importance of capturing interactions between features, techniques for creating interaction features, product features, ratio features, polynomial features, and then the use cases and examples of interaction features in different domains. Chapter 48 will look at dimensionality reduction. So that specifically focus on the introduction to dimensionality reduction techniques like the principal component analysis, linear discriminant analysis, T-distributed stochastic neighbor embedding, and then techniques for reducing dimensionality while preserving information like feature selection and feature extraction. We'll go to the application of dimensionality reduction in high-dimensional datasets. So that will take us to chapter 49, handling time series data. So that will cover techniques for future engineering in time series data, log future, rolling statistics, time-based futures, encoding cyclic features such as timestamps and periodic variables. Then we look at future engineering for seasonal and trend patterns in time series data. So that will take us to chapter 50, which is text future engineering. So we'll look at techniques for future engineering in text data, backup words, representation, term frequency, inverse document frequency, word embeddings, and so on. Then we will also look at advanced text future engineering techniques like the n-grams, word to back, and so on. Handling text data processing, organization, stemming, and lamentization. In chapter 51, we'll be looking at handling imbalanced data. So we'll go through techniques for future engineering to address class imbalance, oversampling, undersampling, synthetic minority, oversampling techniques. So we'll also look at future engineering strategies to capture minority class information. That could be class-specific features, anomaly detection, and others. Then chapter 52 will cover advanced future engineering techniques. So that will cover the introduction to advanced future engineering methods, future hashing, future embedding, future crossing, and techniques for incorporating external data sources and domain-specific knowledge into future engineering. So also look at feature engineering for specific machine learning tasks, recommendation system, neural language processing, computer vision, and so on. Then we will move to Module 6, Introduction to Machine Learning. That will cover definition and importance of machine learning in data-driven decision making. We will look at the overview of supervised and unsupervised and reinforcement learning for paradigms, and then role of machine learning in various domains and applications. Chapter 54 will cover types of machine learning problems. So we'll talk about the classification, regression, clustering, dimensionality reduction, and anomaly detection. Chapter 55 will look at supervised learning. So we are going to have a detailed introduction to supervised learning. I'll talk about the label data, input features, target labels, and the basics of classification and regression tasks. Popular supervised learning algorithms like decision tree, logistic decision regression, support vector machines, k-nearest neighbors, okay, and NN in short. And chapter 56 will look at unsupervised learning, where we are going to talk about the introduction to unsupervised learning, unlabeled data, discovering hidden patterns, and then also look at the basics of clustering and dimensionality reduction tasks. We look at popular unsupervised learning algorithms like the k-means clustering, rich core clustering, principal component analysis, t-distributed stochastic neighbor embedding. And then we'll move to chapter 57, which is evaluation metrics for machine learning models. So that will cover overview of evaluation metrics, accuracy, precision, recall, F1 score, and so on. And also look at the selection of appropriate evaluation metrics based on the problem domain and model requirements. And also the techniques for cross-validation and model evaluation. Chapter 58 will cover bias variant trade-off. So you will be able to learn the understanding the bias variance trade-off in machine learning, balancing model complexity and generalization performance, techniques for mitigating bias and variance, like regularization, ensemble methods, and others. Chapter 59 will look at the future selection and importance. So we'll look at the techniques for selecting relevant futures, the filter methods, wrapper methods, embedded methods, the importance of future selection in improving model performance and interpretability, and then future importance calls like information gain, future important plots, like that. Chapter 60, hyperparameter tuning. So that will cover the introduction to hyperparameters and their impact on model performance, techniques for hyperparameter tuning like grid search, random search, Bayesian optimization, and then the importance of cross-validation in hyperparameter tuning. Chapter 61 will talk about model interpretability and explainability. So look at the importance of model interpretability in real-world application, techniques for explaining machine learning models, future importance, partial dependence plots, and so on. Then the trade-offs between model complexity and interpretability. Chapter 62 will cover advanced topics in machine learning. So we'll look at ensemble methods like bugging, boosting, stacking, deep learning, neural networks, convolution neural networks, recurrent neural networks, and then also reinforcement learning, it's the Markov decision processes, Q learning, policy gradients, and so on. Then we will go to module 7, which is model building and evaluation. So we'll continue from we'll continue to chapter 63, which will look at model development workflow. So we're going to look at the overview of the model development process and data processing, model selection, training, evaluation, and deployment. Then the importance of iterative model development and refinement. In chapter 64, we'll be looking at selecting the right model. So we will be look at the introduction to model selection criteria, the model complexity, interpretability, performance matrices, and others. And then also considerations for choosing appropriate machine learning algorithms based on the problem domain and data characteristics. In chapter 65, I will cover model training and validation, where we'll look at techniques for splitting data into training, validation, and test sets. We look at the importance of cross-validation for model validation, like the K-fold cross-validation, stratified cross-validation, and others. Then avoiding data leakage and overfitting during model training. Chapter 66 will look at training supervised learning models. So we'll begin with the basics of training supervised learning models, like the input features, target labels, loss functions, and techniques for optimizing model parameters, like the gradient descent, stochastic gradient descent, mini-batch gradient descent, and others. Then chapter 67 will be covering evaluating model performance. So we'll cover the overview of evaluation metrics for classification and regression tasks in terms of accuracy, precision, recall, F1 score, mean squared error, and R squared. Then also look at techniques for visualizing model performance. That will be like ROC curves, precision recall curves, calibration plots, and others. Chapter 68 will be covering interpreting model results. So look at techniques for interpreting the model predictions like future importance, partial dependence plots, sharp or sharply addictive explanations, values, and then understanding the impact of model futures on predictions and decision making. That will take us to chapter 69, which is model comparison and selection. So that will include techniques for comparing multiple models, performance matrices, statistical tests, and strategies for selecting the best performing model. In chapter 70, we again look at hyperparameter tuning and optimization. So that will go into details, the introduction to hyperparameters and their impact on model performance, techniques for hyperparameter tuning, like the grid search, random search, Bayesian optimization, and importance of cross-validation, in hyperparameter tuning. Chapter 71 will be specifically on ensemble learning. We'll talk about the introduction to ensemble methods like bugging, boosting, stacking, advantages of ensemble learning in improving model performance and generalization, and then implementation of ensemble models using techniques like bugging with decision trees, adder boost, and gradient boosting. Chapter 72, handling imbalanced data. So we'll cover techniques for handling class imbalance in classification tasks like oversampling, undersampling, synthetic minority oversampling technique, and evaluation matrix for imbalanced data sets like precision, recall, curve, Evans square, area under the curve, and so on. Then chapter 73, we look at model interpretability and explainability. So this will cover techniques for explaining machine learning models, future importance, partial dependence plots, and the importance of model interpretability in real-world applications and regulatory compliance. So module 8 will cover deep learning, where we'll talk about introduction to neural networks. In chapter 74, which will cover basics of artificial neural networks, like neurons, activation function, layers, and then the overview of deep learning and its application in various domains. Chapter 75 will look at the building blocks of deep learning. So we'll cover the components of neural network, for example, the input layer, the hidden layers, output layers, type of neural network architectures, and the feed-forward neural networks, convolutional neural networks or CNNs, recurrent neural networks RNN, and generative adversarial networks. Chapter 76 cover activation functions. So we're going to look at the importance of activation functions in neural networks, the popular activation functions, and choosing the right activation function based on the problem domain and network architecture. Chapter 77 will cover loss functions. So look at definition and role of loss functions in deep learning, common loss functions for regression and classification tasks, mean squared error like binary cross entropy, categorical cross entropy, and selection of appropriate loss functions based on the tasks and output type. Chapter 78 will look at training deep neural networks. So this will cover the overview of the back propagation algorithms, the forward pass, the backward pass, the gradient descent, and techniques for optimizing neural network training. 79 will look at convolution neural network. So we'll look at the introduction to CNN and their application in image processing and computer vision, architecture of a typical CNN, and then techniques for building and training CNNs for image classification, object detection, and semantic segmentation tasks. Chapter 8 will cover recurrent neural networks. So this will cover the basics of RNN and the applications in sequential data processing. Example, natural language processing, time series analysis, and the architecture of RNN. We will cover the recurrent connections, hidden states, gated recurrent units, long short-term memory cells. and techniques for training and handling vanishing or exploding gradients in ARA and N. Chapter 81 will look at generative adversarial networks or GAN. We'll talk about the introduction to GAN and the applications in generating synthetic data and image-to-image translation. Then the architecture of GAN, the generator network, discriminator network, and adversarial training process. Then the training strategies and challenges in GAN, like the mode collapse, convergent issues, and evaluation matrix. Chapter 82 will look at transfer learning and fine-tuning. So this will cover concept of transfer learning and its advantages in deep learning, techniques for transfer learning, feature extraction, fine-tuning, pre-trained models, and so on. Application of transfer learning in computer vision, natural language processing, and other domains. Then we'll move to chapter 83, which will cover advanced topics in deep learning. So we'll pay attention, look at the attention mechanisms like self-attention, transformer networks, reinforcement learning with deep neural networks like deep Q-learning, policy gradients, and deep learning for sequence-to-sequence tasks, like machine translation, speech recognition, and so on. And then chapter 84 will talk about ethical considerations in deep learning. So we'll look at the ethical challenges and biases in deep learning algorithms, strategies for addressing fairness, transparency, and accountability in deep learning models. Then the importance of ethical considerations in AI and the responsible development of AI systems. After that, we'll go to module 9, which is model deployment. So we'll talk, chapter 85 will cover introduction to model deployment. So where we're going to look at definition and importance of model deployment in the machine learning life cycle, an overview of deployment process from trained model to production ready application. Yeah, thank you so much, Rose. It's going to be very interesting. In chapter 86, we look at deployment environments and infrastructure. So this will cover the overview of deployment environments, cloud, like cloud. We'll look at the platforms like the AWS, Google Cloud Platform, Microsoft Azure, on-premises servers, and edge devices. Then we'll look at the consideration for selecting deployment infrastructure in terms of scalability, availability, security, and the cost. Thank you so much. Gracias. You're welcome to the course. In chapter 87, we look at containerization and orchestration. So we'll talk about the introduction to containerization techniques like Docker, Kubernetes, and then look at the benefits of containerization for model deployment. We'll talk about the portability, the scalability, and reproducibility of it. Then the techniques for containerizing machine learning models and dependencies. Someone is asking, is ARA good? So yeah, ARA and Python are majorly used or are the two main programming languages used in data science, machine learning, and artificial intelligence. So we are going to be learning both languages. That is the good part. In chapter 88, we'll talk about model serving and inference, where we'll cover overview of model serving, exposing trained models as APIs for inference, techniques for serving machine learning models, like talk about the RESTful APIs and the serverless function, and then implementing real-time and batch inference pipelines. So chapter 89 will look at continuous integration and continuous deployment. We'll talk about the importance of CI and CD pipelines in automating the deployment process, setting up your CI and CD pipelines for machine learning projects like the version control, the automated testing, and model validation. We'll also cover techniques for integrating machine learning models into existing CI or CD workflows. In chapter 90, we'll talk about the scalability and load balancing. So this will cover strategies for scaling machine learning deployments to handle increased traffic and workflow, and then the load balancing techniques. And then we will go to auto-scaling solutions for dynamic workload management. In chapter 91, we'll cover monitoring and logging. So we'll look at the importance of monitoring and logging production machine learning system, key performance metrics for monitoring deployed models, like the latency, the throughput, the error rates, and so on. Where can I download these documents? I'm going to share with you the link where you can download this document, please. Uh, then we'll look at the techniques for logging the model prediction, input data, and model performance matrices. Then chapter 92, we will look at model versioning, and rollbacks. So strategies for model for managing model versions and deployments, and then techniques for rolling back the model deployments in case of failures or regression, and also the version control best practices for machine learning models and artifacts. Chapter 93 will cover security and compliance. So look at consideration for security in machine learning deployments, like the data privacy, the model security, access control, and then the compliance requirements for deployed machine learning systems. We'll also cover techniques for implementing the encryption, authentication, and authorization mechanisms. Chapter 94, we are going to will cover model governance and maintenance, like the importance of model governance in ensuring fairness, accountability, and transparency, and then techniques for monitoring model performance and drift detection, concept drift, data drift, and strategies for maintaining deployed models, like retraining the schedules, the model reevaluation, and model retirement. In chapter 95, we are going to look at edge deployment and Internet of Things integration. So we are going to look at the overview of edge computing and its application in deploying machine learning models, and then techniques for deploying models on edge devices. So that will cover like the model optimization, the lightweight architectures, and integration of machine learning models with Internet of Things. Internet of Things devices. So and then we'll go to module 10, which is gathering and pre-processing the 500 days run dataset. So For those who have just joined, this course is based on the 500 days run dataset. So this dataset I collected myself, like every day I wake up in the morning, the first thing I need to go and run. So this lesson will based on this dataset to teach the practical machine learning, data science, and artificial intelligence based on real world dataset. So this is where now we are going to begin putting together all what we have learned in the first 9 modules. So we'll begin using them here. So we have introduction, the 500 days run dataset. We are going to look at the overview of this 500 days run dataset, the purpose, the scope, and the characteristics, and also the importance of pre-processing the real-world dataset for machine learning and analysis. And then we'll go to chapter 97, which is the data collection techniques. So we're going to look at overview of data collection methods, above manual data collection, the sensors, the web scraping, the APIs, and techniques for collecting the running data, like using the GPS trackers, the fitness apps, the wearable devices. So I'm using these techniques to collect the data, the 500 days run data. And then we'll go to chapter 98, which will cover data quality assessment. So we look at the importance of data quality in machine learning and analysis, techniques for assessing data quality, validity, accuracy, completeness, and consistency, and then the data profiling methods or summary statistics. The data, this will include the summary statistic like the data distribution, the value frequency analysis, and so on. Chapter 99 will look at data cleaning and pre-processing basics. This will cover the overview of data cleaning techniques, handling missing values, outliers, and inconsistencies. And then also the techniques for data pre-processing, data normalization, standardization, scaling. Addressing data quality issues like the duplicate records, encoding errors, formatting inconsistency. And then chapter 100 will look at handling the missing values and outliers. So this one will cover the identification and treatment of missing values, imputation techniques, deletion strategies, techniques for detecting and handling outliers, or visualization methods, statistical approaches, the impact of missing values and outliers on downstream analysis and modeling. And then we'll go to chapter 101, which is data transformation and future engineering. So where we'll cover techniques for transforming and engineering features, like creating new features, encoding categorical variables, extracting information from timestamp, and then feature scaling and normalization method. And the min-max scaling, Z-score normalization, then the robust scaling. And also look at strategies for future selection and dimensionality reduction. Chapter 102 will look at time series data preprocessing, where we are going to talk about the introduction to time series data and its characteristics, techniques for preprocessing time series data, like resampling, interpolation, handling irregular timestamp, and future engineering for time series analysis, log futures, rolling statistics, time-based futures, and so on. In chapter 103, we'll talk about text data preprocessing and we'll talk about preprocessing techniques for text data, like the tokenization, stemming, lamentization, stop word removal. So remember, the previous modules. We have talked about this now. This will be the practical bit of it. Handling special characters, encoding issues, and other text-related challenges. Then introduction to natural language preprocessing. Chapter 104 will be looking at handling imbalanced data, and then 105 advanced data preprocessing techniques, and 106 will cover data preprocessing pipelines. Then module 11 will look at exploratory data analysis with the 500 days one dataset. So look at almost we had already covered this in the previous chapters, but this is now going to be the practical bits on it based on the 500 days one dataset. So comparative analysis of routes. So we're going to do comparison of different running routes, visualizing and analyzing differences in distance, elevation gain, difficulty, and scenery, identification of preferred routes and common routes among runners. We'll also look at in-depth analysis of performance metrics, and then exploring correlations and relationships. So we're going to look at the analysis of correlations between running variables, distance and pace, elevation gain and heart rate, weather conditions and performance, then identification of significant relationship and their implication for training and performance optimization. We're going to talk about interactive visualizations and dashboards. So we'll look at the creation of interactive visualization and dashboard for exploring the 500 days run dataset. Integration of interactive elements for filtering, zooming, and drilling down into specific aspects of the data. And then a module 12 will be building the predictive models with the 500 days run dataset. So we are going to look at definition and importance of predictive modeling in the context of the 500 days run dataset, the overview of predictive modeling techniques and their application in sports analytics, and then defining the predictive and the prediction targets, identification of the target variable for prediction, performance metrics like pace, duration, the running performance categories, and personal best time, and understanding the significance of prediction target in model development. Then in chapter 122, we look at data preparation for modeling, splitting the dataset into training and testing sets, and then future engineering and selection. And we go to another chapter which will cover the baseline models and performance matrix. So building the baseline models for comparison, and then evaluation matrix for regression tasks. Then we go to linear regression models, tree-based models, support vector regression, neural network models, and then model evaluation and selection, model interpretability, explainability, and then model deployment and operationalizations. Then advanced topics in predictive modeling. Then in module 13, that will be based on real-world application and case studies. So what are we going to cover there? We'll look at introduction to real-world applications. So overview of real-world application of data science and machine learning in sport analytics with a focus on the running performance. Then the importance of applying predictive models and analytics techniques to optimize training and performance. We will look at the use of predictive models to forecast the running performance metrics in terms of pace, duration, and so on, based on the training data and environmental factors. Then the case studies demonstrating how athletes can use predictive analytics to adjust training plans and optimize performance. We'll also look at the injury prediction and prevention in Chapter 1 and the 34. So this will cover the application of machine learning modules to predict injury risk based on running biomechanics, training load, and historical injury data. Case studies showcasing how predictive analytics can help athletes and coaches identify injury-prone patterns and prevent injuries through targeted intervention. And then we'll look at personalized training recommendations, where we will look at the use of machine learning algorithms to generate personalized training recommendations and workout plans tailored to individual runners' goals, abilities, and preferences. And also the case studies illustrating how personalized training recommendations can improve adherence, motivations, and performance outcomes. In Chapter 136, we'll cover the performance benchmarking and goal setting. So this one will look at utilization of data-driven benchmarks and performance matrices to set realistic goals and track progress over time. We look at the case studies demonstrating how athletes can leverage performance benchmarking to monitor improvements and adjust training strategies accordingly. And then the rest strategy optimization. So this will cover the application of predictive models and analytics techniques to optimize race strategies, pacing strategies, and fueling strategies based on course characteristics, weather conditions, and individual fitness level. So look at case studies showcasing how data-driven race strategy optimization can lead to better race outcomes and performance achievements. And then in chapter 138, we'll talk about the technical analysis and race simulation. So we'll look at the use of machine learning models to simulate race scenarios and analyze tactical decisions in real time. Uh, so we'll be looking at case studies illustrating how race simulation and tactical analysis can help athletes develop strategic insights and make informed decisions during competition. And then chapter 139 that will cover nutritional optimization and fueling strategies. So that will look at integration of nutrition data and dietary patterns with running performance data to optimize fueling strategies and enhance endurance performance. So we are going to look at the case studies demonstrating how athletes can leverage nutritional optimization to improve the energy levels, the recovery, and the overall performance. And then in chapter 140, we'll talk about the social impact and community engagement. So this will cover the exploration of the social impact of running and analytics and machine learning technologies on the running community. So look at the case studies highlighting initiatives that use data science and analytics to promote inclusivity, diversity, and accessibility in running. In chapter 141, that will cover the ethical considerations and privacy concern. And then 142 will cover future trends and emerging techniques. Then in module 14, that will cover the conclusion and next steps, so where we are going to look at the recap of key concepts. So that will include the summary of key concepts and techniques covered throughout the course, including data science fundamentals, machine learning algorithms, and real-world applications. And we'll be having the reflection on the learning journey and achievements made by learners in understanding and applying data science, machine learning, and artificial intelligence concepts. We'll also cover the practical applications and case studies. So have a review of practical applications and case studies discussed in the course, highlighting how data science and machine learning techniques can be applied to solve real-world problems. We'll also cover the impact of AI and ML in various industries. So we'll have discussion of the impact of artificial intelligence and machine learning technologies across different industries from healthcare and finance to sports and entertainment. And then the challenges and limitations. So we'll be having the exploration of the challenges and limitations associated with data science and machine learning, including issues related to data quality, model interpretability, and ethical considerations. And then the insights, we look at the insights into the emerging trends and future directions in artificial intelligence and machine learning, such as deep learning, advancements, reinforcement learning, and AI ethics. Encouragement for learners to continue their learning journey in data science and machine learning throughout further education, projects, and practical applications. Then you will also receive recommendations for additional resources, including books, online courses, research papers, and conferences to deepen understanding and explore advanced topics in data science and machine learning. And then also we look at the importance of community engagement and networking in the field of data science and machine learning, including participation in online forums, meetups, and professional organizations. Then we'll cover the overview of career opportunities and pathways in data science, machine learning, and artificial intelligence, including roles in data analysis, machine learning, engineering, and AI research. And then also we'll cover the emphasis on personal development and the importance of a growth mindset in mastering new skills, overcoming challenges, and achieving career success in the field of data science and machine learning. We'll also give invitation for learners to provide feedback on the course structure, content, and learning experience to facilitate continuous improvement and refinement of the future offerings. Then recognition and gratitude for the contribution of instructors, mentors, peers, and supporters who have played a role in the learning journey and success of the course participants. So those are the things that we are going to be covering in this course as far as Python and R for data science, machine learning, and artificial intelligence is concerned. I'm so inspired to go with you throughout this long journey until we complete. It's going to be very interesting. So keep following every day. I'll be here to share with you the office hour and sharing with you, getting to understand the challenges that you are facing, your feedback, what improvement can be made. So I'm going to share with you this document. I think I will share a link where you can download this document. Thank you for tuning in today. A number of people who have joined in: Rose, Gracia, Spaceboard, um, Baska, Pawan. I hope I'm pronouncing your name well. Thank you for joining. See you tomorrow in day 5 office hours. Bye bye.